Hi everyone, sorry for the wait. Thank you so much for being here. I'm really excited to get to speak to you all on day one of RailsConf 2023. We all made it to the end of the day, well done. Today I'm going to tell you the story of how we migrated from MySQL 2 to Trilogy in Shopify's largest Rails code base. Before we get started, let me introduce myself. My name is Adrianna. I'm a senior software engineer and I work for a company called Shopify. Shopify is an e-commerce company. We offer a variety of products for online and in-person retail. I currently work on a team called Scalable Rails Apps. Our job is to ensure that Shopify's Rails applications are easy to build, maintain, and refactor. We ensure that our apps are using Rails the right way and that Rails continues to evolve to meet Shopify's needs. I'm based in Ottawa, Ontario, in Canada. It is finally starting to get warm in Ottawa, which I'm very happy about. I've been working with Rails since starting at Shopify in 2016. I'm currently a member of the Rails Trilogy team. I'm really passionate about open source software development and about making the Ruby and Rails communities more diverse and inclusive. Speaking of, I currently help run the WMB.RB meetup. WMB.RB is a Ruby community for women and non-binary individuals. We hold virtual meetups once a month. If you're interested, please come talk to me about that later. Outside of work, I like to lift heavy things, spend time outdoors, especially with my dog. I am a proud dog mom to Jasper. He is a big baby. He's a Rottweiler, but we like to joke that he's a Batweiler because he often hangs upside down like this. But we're not here to talk about my dog today as much as I would like to. We're going to talk about Trilogy. If you've never heard of Trilogy before, don't worry. We'll start with an overview of the Trilogy database client. I'll talk about some of the advantages of Trilogy and a few caveats to switching. Next, we'll get our hands dirty and look at some code in Trilogy. We'll talk about the MySQL protocol, and I'll show you how we implemented a feature in Trilogy that was necessary for our Rails monolith. Then, we'll go over the changes we needed to make to our code base to switch from MySQL 2 to Trilogy. And finally, we'll talk about how we deployed a large change like this to production. We'll go over what kinds of results we saw after switching, and there's going to be a special surprise announcement at the end, so stay tuned. We're going to use this analogy of climbing a mountain to talk about the journey we embarked on when trying to switch from MySQL 2 to Trilogy at Shopify. Our goal was to run Trilogy in production. That was our summit. But the path up wasn't very clear. We weren't sure what incompatibilities might exist between MySQL 2 and Trilogy, or what risks there were to consider. Where did we even start? It became clear that before we could start our trek up the mountain, we needed to get out our proverbial map and grasp the lay of the land. So that's where we'll begin our story today. Let's get started on our journey by talking about the Trilogy database client. So Trilogy. Trilogy is a MySQL database client with Ruby bindings. Client is any program that can communicate with a MySQL server and issue commands. It was open sourced by GitHub in 2022. Matthew Draper from GitHub wrote a really great blog post about it last year. It's linked at the bottom of the slide there. Please give it a read if you're interested in Trilogy. But the cool thing about Trilogy is that it uses a custom implementation of the MySQL network protocol. What does this mean? This means that Trilogy defines its own low-level API for communicating with a MySQL server. Most client programs rely on libMySQL client, a C library that is distributed with MySQL, in order to talk to a server. For example, MySQL 2, very popular database client gem with Ruby bindings, needs to link against the libMySQL client library, but Trilogy does not. Trilogy supports the most frequently used parts of the protocol, including the authentication handshake, which we'll talk a little bit more about later, and the ping, query, and quit commands. And overall, Trilogy is designed for flexibility, performance, and ease of embedding. So why might you want to switch to Trilogy? We talked about this a little bit already, but minimal dependencies required for a compilation. Trilogy doesn't depend on libMySQL client or an equivalent C library like libMariaDB, which means a couple of things. First of all, simpler installation. You don't need to install and link against the libMySQL client library or deal with compiler flags or anything like that. It's pretty easy to get Trilogy up and running. It can also eliminate client-server version mismatch issues. Using a different libMySQL client version compared to your MySQL server's version can be problematic. So if we take libMySQL client out of the equation, that simplifies things a lot. It also minimizes the number of times data must be copied when handling network packets, which improves memory usage. Trilogy is also designed to perform efficiently in the context of the Ruby VM. It is conscious about its use of dynamic memory allocation, and the API is designed to use non-blocking operations and I/O callbacks where possible. Of course, switching to Trilogy has some caveats. The first of those being that there are still a few incompatibilities with MySQL 8 related to features such as authentication plugins. If your application is already on MySQL 8, this might be something to consider. It's also not as feature complete as MySQL 2 and libMySQL client, so Trilogy might not be a good fit for your application if your application has a lot of custom database configurations. Trilogy was also fairly recently open sourced. The documentation is still a work in progress. It may not be as robust as other client library options, but if you're looking for an open source project to contribute to, consider taking a look at Trilogy. So we're all at RailsConf, so let's talk Trilogy and Rails. We know that Active Record is Rails' object relational mapping library, or the library with all the database stuff. So GitHub released an Active Record adapter for Trilogy alongside the client code. It's external to Rails, so it needs to be installed separately from Rails. But to set Trilogy up in your Rails application is super simple. In your gem file, you'll need to install the database client gem and the gem for the Active Record library. Then in your database YAML, or using the database URL environment variable, you'll need to set the adapter to Trilogy. That's pretty much it. So why did Shopify make the switch to Trilogy? There were a couple of things we hoped to accomplish by switching. First of all, a better developer experience. We were experiencing a ton of compilation headaches with MySQL 2 and its dependency on libMySQL client, especially on macOS. Our hope was that Trilogy would greatly simplify the process of getting a Rails app booted locally with a MySQL database. We were also hoping for some speed-ups in query performance, given that Trilogy was claiming to be performant in the context of the Ruby VM. We were also keen to move to a library with a strong sense of maintainership. Not only does Trilogy have a number of active contributors, but we had several engineers at Shopify who had worked on the library while it was being developed at GitHub and could offer their support. All along the way, though, we had a loftier target in mind. So Aaron Patterson and Eileen Ushitel were the original advocates for open sourcing Trilogy while at GitHub. Now they work on Shopify's Ruby and Rails infra team. So if we have managed to adopt Trilogy at Shopify, they were confident we could make the case to actually upstream the adapter to Rails. This would result in even bigger maintainership for Trilogy and prevent Trilogy from ever deviating from Rails. So we were really excited about the impact we could have by adopting Trilogy in our monolith and making this eventually a Rails community standard. Okay, so we've got our bearings a bit, we've looked at our map, and we have an idea of what moving to Trilogy entails. Let's take those first couple steps up that mountain. We'll look at adding a new feature to the Trilogy client that we knew we were going to need in order to adopt Trilogy. Before we talk about the feature itself, we should go over the MySQL client server protocol. In other words, let's go over how a client communicates with a MySQL database. The server listens for connections on a TCP IP port or a local socket. When a client connects to the server, it must first go through an authentication phase before being able to issue commands. This phase looks something like this. First, the server checks whether the host is allowed to connect. If it is, the server will send a handshake or greeting packet. The client is going to respond with an authentication packet. It includes a credential string, which contains things like the username, a scrambled password if there's a password, and optionally an initial database to connect to. The server is going to verify that information and respond with OK or an error. If the server responded with an OK packet, the authentication was successful, the client can begin issuing queries to the server in what is known as the query phase. So the client sends a command packet to the server. It contains a command code, which indicates which command we want to perform. There are a bunch of different commands. Here are some examples. Comping asks the server to respond with an OK packet if it's alive and reachable. Comquery, very commonly used, it tells the server to run the provided query. Comquit tells the server that the client wants to close the connection. So there are a lot of different commands. I've linked to the MySQL docs there if you're interested in seeing what other types of commands can be sent to the server. But back to the MySQL protocol, the server is going to return a response packet. It can be one of the following things: OK or end of file, which generally indicates success; error if something went wrong; or a result set for query commands. One last concept that's important to talk about with the MySQL protocol is protocol capabilities or flags. During the authentication phase, the client and server exchange information about what they're able to do via a bit mask of protocol capabilities. Here are some examples. Client connect with DB indicates that the initial database can be specified during authentication. Client SSL indicates that the client will use SSL encryption for the session. And client multi-statement indicates that the client may send more than one statement per query. Multi-statement support is actually the feature we needed to add to Trilogy, so we're going to talk more about that in a second. But as I mentioned previously, lots of different examples. If you're interested in checking out more about MySQL protocol capabilities, the MySQL docs are linked there. But let's talk about multi-statement support in MySQL. For those of you who've used MySQL before, you're probably aware that MySQL supports the execution of a string with multiple SQL statements, all separated by semicolons. Here's an example of what that might look like. We have a single SQL string here. It contains a number of statements. And if the client supports multi-statements, we can pass that whole string into a query, and the server will execute it. The client needs to be able to tell the server that multi-statements are supported, though. It does this in the authentication phase, which we just talked about, using that client multi-statements protocol flag. By default, this flag is not set, but when set, it indicates that the client can send multi-statement queries. The client can also set multi-statements after connection using a com-set option command. We'll talk about that a little bit later. Okay, so multi-statement support. Turns out, when we were looking at Trilogy, that Trilogy didn't actually have multi-statement support. You might be wondering, why did this matter to us? Why does this matter for Rails? In general, a Rails application may want to be able to send multi-statement queries. From a performance standpoint, this can reduce the number of round trips to the database. However, there was another use case at Shopify that we were more interested in, and that is being able to insert fixtures in bulk. Fixtures are Rails' default way to prepare and reuse test data. With multi-statements, we can insert multiple fixtures into the database at once, which is more efficient. For context, at Shopify, we have about 1,000 fixture sets to insert, some of which have hundreds of individual fixtures. So we really wanted to be able to take advantage of multi-statement capabilities here. So let's take a look at how the MySQL 2 adapter uses multi-statements to handle bulk fixtures. The MySQL 2 adapter implements a multi-statements enabled method that checks whether multi-statements are enabled by looking at the adapter config. It also implements a with multi-statements method. This ensures that a provided block runs in a multi-statement context. If multi-statements are already enabled, we're just going to yield the block. Otherwise, we'll use that set option command to set the multi-statements option on the server for the duration of the block. Now we're moving into the abstract adapter class. The abstract adapter implements insert fixture set, so this implementation is shared across adapters. Adapters are expected to implement with multi-statements to supply turning on multi-statement behavior if the adapter supports it. This is a method we just saw with the MySQL 2 adapter. And then execute bash can be overridden in a concrete adapter class to rely on that multi-statement behavior. So here's execute bash for the MySQL 2 adapter. It combines the fixture insertion statements into the smallest number of SQL strings possible. This is done by progressively adding SQL chunks to a string up until a max allowed packet value is reached. Max allowed packet is the maximum number of bytes that can be sent in a statement to the server. We use abandon results to get the connection back into a usable state. So with multi-statement queries in MySQL, all of the results must be processed before the connection is usable again. Abandon results essentially just throws all the results away so the connection is immediately usable because we don't actually care about processing the results. Okay, so that was a quick look at how fixtures use multi-statement capabilities in the MySQL 2 adapter. Now let's talk about implementing multi-statement inside of Trilogy. Here we have a header file for Trilogy's low-level protocol API. Don't be alarmed if this syntax does not look like anything you've seen before. The important bit is that Trilogy defines an enum with all of those client protocol flags. The value for the multi-statements flag was already encoded in the library. It just wasn't being used anywhere. So a reminder that multi-statement capabilities can be set in two different ways. At connection time, when we initialize the Trilogy client, or after we've already connected by sending a set option command to the server. Let's start with that first requirement, being able to initialize new clients with multi-statement set. I'd like to give a huge shout out to Parth, who is here in the room today. He works on Rails Infra with me at Shopify. He spearheaded a lot of this work. Let's give him a clap for Parth. So yeah, thank you, Parth, for spearheading a lot of this work. Just a quick note, we are working with a C extension here. It is our bridge between Ruby and the underlying Trilogy library, which is written in C. You don't need to understand a whole lot about C extensions. Just know here that we're writing C code that will be used by Ruby. So this method is our Trilogy client constructor. When you call Trilogy new, this is the code that gets executed. The client constructor accepts an options hash. We check that hash for the multi-statement option. On the Ruby side, that would look like passing in multi-statement true. If the multi-statement option is set, we add the multi-statements flag to the capabilities bitmask on the connection. Cool, so we can set that flag on the client, but what about processing multi-statement results? We ended up splitting the API into two parts, modeled closely after the MySQL 2 implementation. So the first method there is more results exist. It's used to ask whether there are more results in a multi-result set. The second is next result, which is used to actually fetch the next result from the query response. Both rely on a more results exist flag that is set on the response packet that comes back from the server. When set, this flag indicates that more results are available to be read on the result set. So we perform a bitwise AND operation to determine if the flag is set, and that essentially dictates the behavior of both of those two methods. On the Ruby side, we can use the API like this. With multi-statement turned on, if we send a multi-statement query, then we can continuously call next result to process results as long as more results exist. So that's requirement one covered. But what about allowing multi-statements to be set after connection? Remember that we need this for with multi-statements in Rails, which needs to be able to enable multi-statements after the connection is already established. Now this change required us to touch the Trilogy C API because at the time, there was actually no way to send a set option command from the Trilogy client. We were going to need to build a set option API into Trilogy itself. So another quick reminder, Ruby interfaces with the Trilogy C API through a C extension. The C extension is where we were working in the slides prior to this, but now we're going to be working with the C API directly. Commands in the client are split into send and receive functions. This allows callers to wait for I/O readiness. The set option command thus needed to be split into two parts, a send function and a receive function. So this is what the send function ended up looking like. It's pretty simple. It builds a set option packet. We'll take a look at that method in a moment, and it writes the packet to the connection socket. So Trilogy builds set option packet. This method does pretty much exactly as its name suggests. It is going to build a packet for the com_set option command containing the server options of set. So if we break it down a little bit, that server option that gets passed in needs to be a Trilogy set server option type. There are, funnily enough, only 2 options that can be set according to the MySQL protocol. Those are multi-statement on and multi-statement off. We build a packet with the value for com_set option, which is that hex value at the top there, and the specified server option that was passed in, and that completes our set option packet. So now onto the receive function. Pretty simple again. Its job is to read the response packet from the server into our connection buffer and handle the result. Okay, we're almost done. We're gonna put it all together now. We have a way to set server options on the C side, but we need a way to do this from Ruby. We're moving back into C extension land. So we're gonna expose a set server option method on the Ruby side. This method will call Trilogy set option send, the method we just introduced in the C API, with the specified option. Once the com_set option command has been sent, we wait to get a response back from the server via Trilogy set option receive. And then the rest of this function is just breaking and returning true on success or handling timeouts or errors. Okay, so now in Ruby, we can go ahead and do this. We can initialize a client without the multi-statement option. However, if we then use that set server option method and pass in the multi-statements on option, this will enable multi-statement capabilities, and we can go ahead and send a multi-statement query to the server. Okay, so we're gonna go back to Rails now. We're gonna apply the new multi-statement behavior we added to the client to the active record adapter. This is the code for the Trilogy adapter. You'll notice it looks very similar to the MySQL2 adapter. We can basically ask whether multi-statements are enabled by checking the config, and then with multi-statements, we'll use our new set server option method to enable multi-statement capabilities for the block. Here's a quick refresher on how fixture insertion works in Rails. The abstract adapter implements insert fixture set. Adapters are expected to implement with multi-statements in order to enable multi-statement behavior. And execute batch can then be overridden to make use of multi-statements. So execute batch in the Trilogy adapter looks like this. Again, very similar to the MySQL2 implementation. Actually, the only difference is that Trilogy doesn't implement abandoned results. There are reasons for that that are documented in the repo if you're interested, but instead of using abandoned results, we need to iterate through the result set to get the connection back to a usable state. Okay, so that was a look at implementing multi-statements in the Trilogy database client and in the active record adapter. I have links to the relevant PRs there if you are interested in seeing the PRs. But let's head back to our climb up this mountain. So after building multi-statement support into Trilogy, we were ready to try to use Trilogy in our monolith. Now, spoiler alert, aside from some small API changes, it was pretty simple to migrate from MySQL2 to Trilogy. Trilogy is considered a drop-in replacement for MySQL2. If you're thinking about moving to Trilogy in an existing Rails application that uses MySQL2, here are the steps we took and some of the things you should watch out for. So step 1 is to set up your application to use Trilogy. We needed to install the gem for the active record adapter and the gem for the Trilogy client. We were using the Edge versions of both, but feel free to point to the latest stable release. We were just using Edge because we were shipping some changes and wanted to be able to have those changes on our branch. You will also need to set the adapter to Trilogy in the database YAML, or set that database URL depending on how your database is configured. But that should be all it takes to get Trilogy going in your application. The next step is to address differences in the API when working directly with the database client or client results. Most of the time, we go through active record APIs when dealing with the database, so it should be relatively uncommon to need to interact with the client directly. However, if there are any places where you are interacting with the client, you'll need to watch out for some small API changes. Here's an example. We have a method that executes some custom SQL on the database connection and enumerates the result. With MySQL2, calling execute with the query would get us back a MySQL2 result object, and we'd enumerate that result using each as hash. With Trilogy though, we get back a Trilogy result object, and to enumerate it as a hash, we need to use this each hash method. So fairly simple API change there. Here's another simple example. MySQL 2 has a query options method that exposes the options that are passed in when the client is initialized. We were using this method to grab the host and port for the current connection for use as a cache key. Now, Trilogy had a query flags method, had the concept of query flags, and it is a bit mask that controls options that can be set at query time. For example, things like casting options. And this is different from MySQL 2's query options. Trilogy's query flags actually don't have any relation to the initial connection options. We needed to add a method to Trilogy to expose options passed in at connect time, but we didn't want to name it query options because we thought that might be confusing with the existing query flags method. So we ended up just naming it connection options. If you were using query options on the MySQL 2 client, you'll now need to use connection options instead. Finally, we needed to address differences in the error classes. This one's pretty simple. If you're rescuing MySQL 2 errors directly, you'll need to change these to rescue Trilogy's base error class instead, which is Trilogy error. Trilogy overall exposes comparable errors to MySQL 2. For example, there's a MySQL 2 timeout error and a related Trilogy timeout error, as well as a MySQL 2 connection error and a Trilogy connection error. So the mapping should be pretty straightforward. If you're rescuing specialized MySQL 2 errors, there should be an equivalent Trilogy error to rescue. The error messages will differ though, so if you're checking explicit error messages, make sure to adjust those if you switch to Trilogy. There is one key difference in connection-related error handling between MySQL 2 and Trilogy, and that is the following. If the database is down, MySQL 2 raises a connection not established error. So this is a test from our Monolith. It basically just asserts that if we simulate the database being down, we see this connection not established error. But this is going to be a little bit different in Trilogy. With Trilogy, Trilogy will actually opt to close the connection client side if it cannot talk to the server. This means that if the database is down, Trilogy will surface that as a Trilogy closed connection error. And the Trilogy adapter translates those connection closed errors to active record connection failed. This means that the error will show up in Rails as active record connection failed instead of active record connection not established. So if you're testing anything related to the database being down, you may need to adjust some of your test assertions to work with Trilogy. You should also ensure that anywhere you're rescuing connection-related errors, you rescue both connection not established and connection failed. Okay. So at this point, our CI was green, the end, our summit was in sight. We were really excited to try things out in production. However, we were a little bit wary of deploying a massive change like this all at once in case something broke unexpectedly. We needed to come up with a plan to safely roll things out. Before we talk about the process we took to deploy Trilogy to production, let's zoom out a bit and talk about the Rails app we were migrating. So most of Shopify's e-commerce software lives in a Rails app called Shopify Core, a modular monolith. To give you an idea of what kind of load our database infrastructure needs to support, over Black Friday, Cyber Monday 2022, which is a really big weekend in e-commerce for us, our MySQL fleet handled 14 million queries per second at peak. So that's a lot of database load. This is a very simplified view of our database infrastructure. It'll come into play a little bit later on, so bear with me. But Shopify Core is a horizontally partitioned Rails application. We have a fleet of MySQL instances running on Google Cloud Platform, managed by Chef. Our MySQLs are distributed in clusters across multiple regions, and we use ProxySQL. So ProxySQL is a protocol-aware proxy. It sits between MySQL clients and MySQL servers, and it essentially multiplexes about 100,000 client connections from our Rails application to roughly 2,000 backend connections to our MySQL fleet. We're going to come back to ProxySQL in a little bit. So let's talk about how we deployed Trilogy to production. To start, we decided to run the Trilogy database client on 1% of production traffic. We did this by exporting an environment variable to 1% of our pods, and then configuring the database adapter in our database.yaml based on whether this environment variable was set. So experimental group was the environment variable we exported. We set it to Trilogy client on 1% of our pods, and then the database adapter was set to Trilogy for those pods. This change meant that we needed to support both MySQL 2 and Trilogy in our application code. So anywhere we were dealing with the client API directly, we needed to switch on the connection class and handle the differences in the API. One question we had, though, was how should we handle our tests? We didn't want to create a whole new CI pipeline for Trilogy because we have a very big CI suite, and that was going to be too expensive. We also didn't want to remove MySQL 2 test coverage because the majority of production was still going to be using MySQL 2. We thought about running half of our CI workers with Trilogy and the other half with MySQL 2, but we were worried that a failing test might get re-enqueued with another worker and pass on a different adapter, making it difficult to spot bugs. In the end, we decided to keep tests running fully with MySQL 2 and run our Trilogy branch on CI daily for the duration of the rollout period to ensure compatibility up until the point where we were ready to deploy Trilogy at 100%. Okay, so the 1% rollout went smoothly. We saw no issues with Trilogy. We were really excited. We were feeling confident. We decided we were going to ramp it up and try Trilogy out on 50% of production. So ship to deploy. Within a few minutes of deploying, we started seeing elevated error rates. We saw this huge spike in the number of client connections on our primary shard, which was very worrying. We caused a service disruption, so we had to go ahead and ship a revert. As the revert was being deployed, we worked with Shopify's incident response team to try to figure out what the heck had happened. Someone from our database platform team really helpfully piped up and suggested that this is what had happened. So back to our good friend ProxySQL. ProxySQL keeps a pool of backend connections. These are the actual connections to the MySQL servers, and they are shared by the client connections coming from the application. However, if two clients have different protocol capabilities, those protocol capabilities we talked about earlier, ProxySQL needs to perform a change user command to set the new connection options when switching backend connections. So, if Trilogy and MySQL 2 had different protocol capabilities, we'd need to perform change user every time a backend connection was swapped between Trilogy and MySQL 2. So the theory was that all of these change user commands put excessive load on our primary shard and basically overwhelmed the database. We needed to validate our theory, though, and figure out how Trilogy and MySQL 2's connection options were different. We were able to query a ProxySQL pods connection list, which gave us access to which client flags were set across different connections. We saw that MySQL 2 was setting a client multi-results flag by default, but Trilogy was not. Now this flag is very similar to client multi-statements. Multi-statements implies that the client can both send multi-statement queries and get back multiple result sets, whereas multi-results simply indicates that a client can handle multiple result sets. So multi-statements implies multi-results, but not the other way around. And MySQL 2 was setting this flag, but Trilogy was not. So the fix ended up actually being pretty simple. We needed to add that multi-results flag to the default bit mask that's set on the client, and that fixed our problem. Okay, so we were ready to try to run Trilogy on a bigger portion of production again, with that fix shipped to the Trilogy client. But rather than going straight to running it on half of production, we decided to reduce the blast radius a bit by running it at 100% on a single cluster. So we rolled out to 100% on one of our European clusters. We double checked that the protocol capability flags matched between Trilogy and MySQL 2, which meant that ProxySQL could share backend connections between them without needing to change users, and everything looked good. We went ahead and collected some metrics. So this graph shows request time MySQL 2 was taking on average 3.46 milliseconds per request, Trilogy 2.7 milliseconds, which is about 22% faster. Similarly, we looked at MySQL query time. So MySQL 2 took about 1.43 milliseconds per query, Trilogy about 1.24, so about 17% faster. So good results for Trilogy for both of those metrics, which was kind of cool to see. Okay, so we saw no issues running Trilogy at 100% on one of our European clusters. We tried it out for 24 hours, so we decided to take the plunge and roll out to 100%. This is also the point at which we shipped all of our test changes. So our test suite was running fully against Trilogy instead of MySQL 2. And the rollout was successful. We saw no other issues, which was great. So that is the story of our journey to migrate from MySQL 2 to Trilogy at Shopify. There were some challenges along the way. This was largely due to the complexity and size of the application we were trying to migrate. For the most part, as mentioned, Trilogy should be a drop-in replacement for MySQL 2. But the payoff for us of getting to the top was well worth it. At the beginning, I mentioned that embarking on this journey was difficult because the path up the mountain was unclear. My hope is that you can follow the path that we've made and learn from our experiences. So go forth and confidently give Trilogy a try in your Rails applications. And a special surprise announcement as promised. So we actually managed to upstream Trilogy to Rails with 2 large Rails applications running Trilogy in production, being GitHub and Shopify. We were able to make the case for bringing it into Rails as an alternative to MySQL 2. So starting in Rails 7.1, you'll no longer need to install a separate dependency for the Trilogy adapter. It will just ship with Rails. What's next for you? You might want to give Trilogy a try in a new Rails application. You can also try migrating an existing application from MySQL 2 to Trilogy using some of the steps we talked about today. You might consider contributing to the Trilogy client or to the adapter that now lives in Rails. Or you can just flex your new MySQL knowledge on all your coworkers. Thank you so much for coming to my talk. I would also like to extend a huge thank you to all of these wonderful people who helped with Shopify's journey to adopt Trilogy. Couldn't have done it without all of them. If you'd like to hear more about Trilogy, come find me and say hi, or you can tweet at me. My socials are on the slide there. But I appreciate all of your time today. Thank you.